So what did she come up with? We have the equation ln x cannot be evaluated at 0 or a negative number because there's no number that e can be a power of with an outcome of 0 or a negative. Good, I like that. So x has to be greater than 0. Good. F of negative x is impossible. Therefore, there's no, can you clarify that? What do you mean f of negative x is impossible?
You can't plug in negative x for x.
Why?
Because the x is negative.
What happens if x was negative in the first place? Negative x would be positive. I'm leading you here. You already answered the question, really. Can x be negative to begin with at all? No. The entire input set is positive, therefore you can't do that. You can also logic it out as follows. We talked about this a little bit yesterday. If the equation is only, if the domain is in the positive, only for positive values of x, can you reflect that over the y-axis? No. Can you rotate that around the y-axis? No. So the only symmetry we're looking at, you're absolutely right, cannot work. So no symmetry. Yes. Go ahead.
She skipped intercepts.
Oh, man. Oh, no! You just got called out on national television. Okay. Okay, we'll go back. It's okay. It's okay. It's okay. It's okay. It's fine. It's good. We'll staple it together. Asymptotes. Now, here's the thing. Can you what? Can you make it full screen? Yes, I can. Okay. So,
Oh yeah, when I used the latex,
yeah?
it turned infinity into
an A, yeah. Yeah, sorry. Okay, so you're looking at what happens as the limit as it goes to infinity. That's supposed to be infinity right there, right? As x goes to infinity, the limit does also. Sure. Okay, we got that. Therefore, there is no horizontal asymptote. I like that. It does get infinitely big. ln x gets infinitely big as x gets infinitely big, and so does x. So if you multiply them, they're definitively getting bigger. Since the function is continuous on its domain, there's also no vertical asymptotes. I like that. That's very clear and concise, and it's a complete sentence with nouns, verbs. You know, I like that. There's a period. Excellent. Very good. Okay, so for intercepts, though, is there one intercept? Raise your hand if you think there's an intercept. Yay, there is one. Where's the intercept, Bill? X equals 1. It's at x equals 1. If you said the intercept is 1, is that correct? No, you have to need more information. You were correct. X equals 1. So at 1, 0. You're absolutely correct. Okay, hold on. I'm gonna why we know there's an intercept at 1, 0. F of x was what? X ln x all squared, right?
Yeah.
Well, ln x never equals 0, right?
No.
Yeah.
Yes, it can.
Yeah.
Oh, it can. Sorry.
Yeah.
Duh. Okay. Yeah, I love that. Ln x equals 0 when what?
When x equals 1.
X equals 1. Can x equal 0 in this?
No.
No, because you can't plug 0 into ln x. Yeah, you're absolutely right. So it's 1, 0. Are there any others?
No.
No, there are no others. We know this particularly can't have a y. We've already determined this can't have a y-intercept. Why?
Because the y-intercept is not, or the y-axis is not.
X can't be equal to
is
0.
in the not.
Exactly. You all said the same. That was very good there. I like it when we get a harmony of agreement here and said different ways. The y-axis is not part of the domain. X equals 0 is not part of the domain. It's not part of the domain, so therefore you can't cross it. Okay, so we're through the beginning 5% of this, which is good. Okay. No, I mean, it's fine. It's just we have to do a little more, don't we? So what did she do here? Let's see here. She... Why isn't this... Oh, because I'm turning the thing as well. I didn't understand why it wasn't moving.
Why is it not working?
I couldn't figure it out, okay? Okay, so we have the first derivative. What'd you have to do for a derivative? What rule were you using right there? Chain and product. And then you got that, and then you factored out ln x. I like that. Great. So when x equals 1 or x equals e to the negative 2, f of x equals 0. I like that. That's good. That's great. So then you made this chart because you're interested in finding out where is it increasing and where is it decreasing. I think we figured out where one person made a mistake, or in some realm, or he just likes hitting his sword. Go ahead.
How do you solve for e to the negative 2x?
Okay, well, you know that there's two things here. There's ln x, and then there's ln x plus 2, right?
Yeah.
So the first one equaling 0, you know that's when x equals 1, correct? So the second one, you're right. How did she do that? You could ask that question. That's fine. You have ln x plus 2 is equal to 0. You're solving this, right? You're solving that.
And then you can just take the inside ln x plus 2.
ln x plus 2 is equal to 0, right? So ln x is equal to?
-2.
This is log form. What form do you need to transfer it into?
Exponential.
Exponential form. So e to the negative 2 is equal to x, which is, and just so you can estimate that, that's 1 over e squared, right? E is like 2.7, so that's going to be like around 1 over 8 point something,
Yeah.
you know, so like around 1/9. So you have an idea of where it is. And is that within the realm of what you're expecting?
Isn't that going to be
Yes.
more around like 1 over 5?
2.5 times 2.5 is No,
wrote that down.
6.25, so 2.78 is gonna be bigger, so it could be
Alright.
6.7. I mean, yeah, it's
It's in
not
that-
like 20. You know,
Yeah.
it's not like out somewhere where you know there really shouldn't be an inflection point. So you're not contradicting yourself yet. The natural log of something less than 1 is gonna be negative, and then you know you have to be real careful here though. If
How negative?
how negative is that is the thing. Do you understand what's going on here? Like you're adding 2 to it because that could be negative, and you add 2, it becomes positive, right? So what you want to do here is your bounds, like the region, and you could draw the line here is 0 to the point of inflection, which is 1 over
E squared.
e squared, right? So you could think about it this way. Listen, you could think about it this way. You can pick something really, really close to 0, right? What is the natural log of something that's really, really, really close to 0? That's a really big what kind of number?
Negative.
Really big negative number. So you, by taking x closer and closer to 0, you can make ln x really, really big
Negative.
negative number. So if you add 2 to that, is that going to make it positive? No. So you know it's going to be a negative, positive, good. And then a half, you know it's going to be negative. For this one, the bound here, you have to be really careful about this. This is the one that you might need to use a calculator on. It's so close, you can't really get it. It's hard to logic out, but you could think about it. The break point is, it's e to the negative 2. If you get really, really close to e to the negative 2, it's always going to be, can it ever be more negative than negative 2?
No.
No, it can get really infinitely close to negative 2, and then when you add 2 to that, it'll always be, like negative 1.99999 plus 2 is what?
Positive.
Positive. So it is possible, you have to be careful, you have to really think about this. Negative, and then it's positive, it's positive, it's positive. Okay, that's nice. So then how did you... Oh, good. So you did the next part nicely. Good. I like this. The maximum when x equals e to the negative 2 because f prime of x is positive before and negative after, and it's a minimum when x equals 1. That's great. So now you have it. You know it's going to go. It's going to rise, and then it's going to fall, and then it's going to go up. What's the next thing you have to do on this though? And I like that explanation. That's good. What's the next thing? We know where the mins and maxes are. What do you have to find next? What? Points. Your points. You do have to find points. What points do you have to find, Chris?
You need to find the points of inflection, the points of the mins and maxes.
Yeah, it would help. Yeah, it'd be nice if you did find that where the mins and maxes are. We know where the min is. It's 1, 0. You plug in 1, you get 0. So now you have to plug in e to the negative 2 and get the max, which you could do. Is this double-sided?
Yeah, it is.
Excellent. Okay, so for concavity here, let's see what's going on. You did the second derivative. Nice. X can't equal 0, so therefore that cannot be an option for a critical point. In the first term of the second derivative, there is no point that would make the term equal to 0. In the other place of the function, the value of x that would make f prime equal to 0 is e to the negative 1. Very good. That's fantastic. So when you put this all together, and you just plug this into, is this Wolfram alpha?
No.
Who Cool. Nice. That looks pretty good. So if we did this right here, this is great. But if you were freehanding this on your test, right? If you were trying to make a freehand on the test, you would need to label the important points. The important points would be, we know some of the x values given what you gave us, but we don't have all of them. We know that this right here is 1, 0, right? And we know that that's a max. And what is that right there?
Well, the x value is
E to the negative 2, right? 1 over e squared. And then we'd have to find out what that is, right? But then we also have to find out, we know that there's an inflection point right here. Do you remember what the x value is right there?
1 over e.
Yeah, e to the negative 1 comma something. Those values would be necessary in order to receive full credit. You need to tell me where they are, especially since you can evaluate the original function at these values pretty easily. When you take the natural log of e to any power, it's just the power. It's just the power, right? Like natural log of e to the negative 2 is negative 2. Understood? So this function is not quite that. It adds something onto it. That's why this stays in the upper positive above the y-axis. But you need to label those points. How do we feel about this system of stuff? What do we think?
Good.